Today I'm going to talk about AI data, privacy, the machine learning experience of using AI data, and fairness. And I think it's important for us all to be on the same page, how like machine learning came to what it is now. So let me start a little bit with a historic retrospective. I think the beginning of machine learning, there was this big divide between what the business needs and what the machine learning community can provide. And for a long time, the executives didn't really know how to communicate it. And in some companies, that is still the problem. But I think we kind of overcame this first problem, this first level of complexity. Most companies know there is like a ranking problem, content understanding problem, as the previous speaker spoke about. And so this communication has really improved. Then the second level of complexity was when the machine learning community started improving the performance. And so they said, hey, we have this algorithm, we need to, kick the shit out of the ROC curve. And so that was very good. On their laptop, it was all working. Then the third level of complexity was when they said, okay, now I have this code on my machine, let's give it to the engineers and put it into production. And so I think scaling machine learning algorithms and putting into production was the third level of complexity. I still remember at Semantic, we had an engineer, he had like a Python notebook, and he's like, good luck, right? So that's the type of handovers I think used to happen, not anymore. Then there was the fourth level of complexity where we put these things into production and the customers and users were like, hey, wait, why am I being rejected for this loan? And so the explainability came along and everyone was like, hey, I need to know what's happening here. Then after explainability has been kind of briefly addressed, privacy came along and a lot of people are like, hey, what did you do with my data? And I understand why you rejected me, but like I didn't give you this data for this purpose. Classical examples is like you do a blood donation and then suddenly they use your blood group to help you with login information. Like what's that, right? And then the last level of complexity, I think the reason why we're all here today is kind of this fairness and responsible AI and AI ethics. And so everyone is like, hey, we have now understand, we know what data you use, but like, are you doing the right thing from an ethical perspective? And so as you can see, as these levels of complexity are evolving, I think I'm going to kind of tell you, if you want to take anything from this talk, I think there is one solution for this, for all of these problems. I call this solution MLX, machine learning experience. I think the truth is we need to kind of broaden our community a little bit and get everyone more involved. And so if we simplify it and make it more transparent, that's what MLX is all about, then suddenly the business executives understand what you're talking about. And they're like, oh yeah, that's the thing that I wanted. The engineers that have not built the algorithm will be able to productionize it much easier. And our friends from customers, they will be able to see why the machine learning algorithm does what it does from a transparency perspective. And our friends from a privacy perspective, a lot of the problems will disappear and go away. The customer doesn't even have to think about it when they build the machine learning algorithm. And from an ethical perspective, you will get like alerts and transparency alerts saying like, hey, you could improve your data here. So MLX is really the key here. And are we still getting the presentation? To be honest, it's not such a great presentation, so don't worry about it. Low expectations, but it just helps me to remember what I wanted to say. So, but let me give you an example of why I think it's so important for all of us to kind of broaden our community. Like, look at the room here right now, right? How many of you would describe yourself as an AI ethics skeptic, right? Think about it, right? Yeah, here you go, right? That's one brave person, right? Thank you. But the truth is, it's important to have dissenting voices, right? And to open up and get all the people that are critical. I cannot overemphasize this. I have seen this a couple of times now in the iteration, where all the well-meaning people come together and they develop really complex algorithms and ideas in terms of like how to fix things. And then they're like, oh man, this doesn't scale to anything. By that time, it's too late, right? So it's very important to have like people that are critical of what you're doing. And I think the solution for this is kind of to develop some sort of like a lingua franca, like a language where we can talk about machine learning algorithms and like all understand, not just like the people that are presenting. I think that's really hard. I don't have solutions for that. But let me tell you about the next level. Like let's imagine we have developed the lingua franca. We have this machine learning experience. We've broadened our community and we got everyone together. The second problem is to actually get the data. I think there is a big gap to be able to solve the AI ethics problems is to have the data, to have the gender, to have the distribution by geography and stuff like that, so you can kind of normalize your data sets. And of course, it's kind of a competing thing against privacy. All right, here you go. I'm gonna do some clicking here. Now this feels good. We're already halfway through the presentation, right? Here you go, all right. So I want to explain you this whole privacy situation using an example. So normally I use like a really controversial example, like who's like voting for Trump or like who doesn't believe in vaccines. But since we just had a great experience with AI ethics skeptics, we're going to play the same game, and I'm going to explain you how differential privacy works using this game. Because I'm kind of assuming, and no one was really brave enough to admit it. So how does differential privacy work? You hold a secret that you don't want anyone to tell, and the solution for getting an average in the room is to introduce some noise. And so how we're going to do the noise introduction here is, in your head right now, imagine whether you have a coin flip, whether it's a tail or head. Okay, so just like flip a coin and remember head or tail. And then what I want you to do is I want you to answer the question whether you are an AI skeptic, AI ethics skeptic, truthfully. If you flipped tail, but if you flipped head, I just want you to randomly answer. Does it make sense? Right, so flip a coin, and if you're tail, tell me the truth, saying, I'm an AI skeptic. But if you are flipped head, just lie to me. Or like say something random, right? It's up to you. Okay, like one more time, so that who is an AI skeptic, right? So you see, now we have this beautiful example where we can compute the average number of AI skeptics here without kind of like bullying any one of you after the talk. Right? So this is how privacy works. Like there is this technologies, really cool technologies that allow you to find out some information without sacrificing the privacy of customers. But what is the flip side on that? The flip side on that is that privacy is not actually just one thing. There are like so many different privacies. Actually, there are about 4 of them, or like many more of them, right? And for example, purpose limitation, like I was giving you the example with the blood group thing, is not actually covered by this, right? Like you gave me the information, and you didn't want me to use it for this purpose. It doesn't matter whether you kept my information anonymous or not. Data minimization, right? Like tell that to these deep learning neural networks that they are not allowed to use too much data. Unauthorized access, Cloudflare bot management was one of the products I developed. And then data retention. Even if I gave you the data, I would like you to kind of stop using it after I'm gone, right? So there are many really interesting solutions for each one of these problems. Like if I had to highlight like one of them, I would say like purpose limitation. There is some really cool stuff happening on like compiler technology, where instead of looking at the machine learning algorithms like as a black box where you don't know what's happening inside, right? I mean, who knows? Like there's some code written, no one really can. The compiler technology opens up that black box and really understands, oh, you're taking an average here. That's okay. But you're now using it for a different purpose. That's not okay anymore. Let me tell you a joke. Now, normally I have in this part of this presentation, I talk about lineage tracking and metadata, but because of the change of the company that I work for, I had to remove the word meta because it's confusing. So, so if you notice that there are very few people talking about lineage tracking from my company, that's the reason. So let's come to the AI ethics part. This is like a classical example of AI ethics, right? Like the smart people in the room here, they all know that we shouldn't answer this question, right? Like just avoid it. Like what's the right answer? No, right? But for some reason, our algorithms feel very, very confident about this, right? Do you know this feeling when you had an exam and you come out and you're like, oh man, I crushed it, and then you get a really bad grade? That's what's happening with our algorithms all the time. And so I think one of the biggest mistakes in this industry right now is there are lots of problems and there are lots of things that need to be like sorted out, and a lot of people get overwhelmed by that. They're like equity, equality, like those debates like very, very hard and no one can answer them. I can't answer them, I'm not gonna try to. But there's some certain problems that I think we can break down. One of them is label imbalance. Like imagine you have all your hateful content coming from one country. Now that could, maybe that's the case. Maybe Russians are hateful. But there is also possible maybe you've made a mistake in sampling. The second one is label bias. Like, who were all the people that did the labeling, what hateful or not, right? In many cases, you like paid like a very low amount of money to some particular country to do the labeling, and then you're surprised that it's biased. And the third one is the model bias. You know, like, why do we keep rejecting loans from this particular zip code? Now, the solutions for some of these problems, for example, label imbalance. I'm not saying that it kind of solves the problem, but looking at the data is a good first step. So I do really encourage everyone to not get overwhelmed by the fact that this is really hard, but just like, hey, let's look at the data. And one of the things that you can do is you can compute odds ratios. So like saying like, hey, we have 99% of girls in this data set and only 1% guys. But all the hateful comments do come from the guys. Is this a good data set to train on? Right, that would be a classical example. And then label bias, as I kind of mentioned, you can create gold data set, and model bias, there are certain predictions of subgroups, you can kind of break it down. That's it. I'm going to skip through the rest, so feel free to Q&A.